गलत टाइम पे कॉल कर दिया तुमने।
Okay, so please sit down, guys. So in the first two classes, we have little bit knowledge about what is this ODI, ordinary differential equations and ODEs, and how it helps to solve the problem and how to solve these problems. Okay. But if you remember in the very first class, I told the application of engineering mathematics, specifically the ODs, why we need them to solve some physical problems, right? So what I will do today is that I will demonstrate, or I will take some example, that some real life problem, and we apply these ODs to solve those problems. So that should be the primary job of the first half. The second half we will discuss about something else. So here let's start about something called some application oriented problems on ODs. Okay, so let's take one example first. Maybe we will try to solve just one or two problems to figure out how it works. So if I write the question here, so I'm writing, please note it down. If an airplane has a run of 3 kilometer, this is 3 kilometer, starts with a speed of 6 meter per second constant acceleration and make a run in minutes, 1 minute, with what speed does it take up? Let me read it out clearly. If an airplane has run of 3 kilometers, starts with a speed of 6 meters per second, moves with constant acceleration and make a run in 1 minute. With what speed does it take up? I believe all of you are a little bit familiar also how the airplane take off. Yes? Okay, screens are off. Okay? No? The screens are on or off? On. Okay. I don't know how to show that. Are they now? Is it visible? No? No? Then I don't know how to fix that one. Is it now?
No, we can change it.
So I cannot fix it. Maybe somebody can help me to call the assistant to fix this.
Just try turning that off and on again.
Okay.
Copy off.
वो स्क्रीन में दिखना चाहिए. Is it now visible? Huh? Screen is off. Is it visible now?
I did try.
Yeah, please. This one is great.
荧幕有电脑画面吗？
有一样的，现在是一样，
现在是这边吗？
现在一样的。现在没有，它其实后面都不会闪，这个是后面都没动，后面都没动。
哦，都一直维持是电脑画面。
对啊。
哦。现在后面荧幕有消失没？
都没有。
都没有。
一样维持电脑画面。
现在是关机了。
现在关机了。
现在有东西吗？
黑色。
黑色的，好。
黑色。
现在有吗？
黑色，黑色，
黑色。有吗？现在有吗？
黑色，
黑色。So this one doesn't work.
Maybe.
Yeah. 有吗？没有。
黑色。黑色，
黑色的。现在关机了吗？
对。
有开吗？
对。哎，出现了。
好的。
哎，好。看一眼。我分析一下。
Thank you. Okay, so we are discussing on application-oriented problem. If you look into this, I believe most of you have some experience how the airplane take off. It will just run in the runway, then at a particular speed it will take off. Right? So few things if you notice here is given. One is 3 kilometers. Let's see what are the things given to us and how we need to find out. Another thing is the speed is 6 meters per second. So this one is the 3 kilometers, the runoff is given 3 kilometers, the speed is 6 meters per second. And the time is 1 minute, that is 60 seconds. We need to find out the speed. We need to find out the speed that we need to find out. Right? And what else is given? Can you tell me? Something else is also given. If you clearly see something is given is acceleration. So I believe all of you understand distance, speed, acceleration. Yes? So it is saying that this acceleration is constant. That means if I write A stands for acceleration, so it is saying this acceleration is a constant. Let's say that constant is K. So that means it is saying A is equal to K. But what is this A? What is this A? Acceleration is what? Speed by time, right? Velocity by time. So I can make it that dv by dt is equal to k. That implies I can say dv is equal to k dt. That implies if I will integrate here, and if I will integrate both sides, I will get v is equal to kt plus some constant c. Is it making sense? Right? So this is what we are supposed to calculate. V, the velocity, the speed, that is V we want to calculate. So we need to find out this V, velocity. That is we are looking for, right? Now if you notice, to calculate V, we need to find out following things. One is the time is given. This t, time is given. We need to calculate this c, the constant, as well as this constant k. We need to find out k, t and c. Then we can get the actual value of v, because here we are not looking for the general solution. We are expecting a particular value for the velocity. Right? Okay. Now, if you look into this question, it is mentioned that the airplane starts with a speed of 60 meters per second. From the beginning it starts with a speed of 6 meters per second. Right? What does that mean? This means, I can write here, this means at time t is equal to 0, the velocity was 6 meters per second. Yes. So if I will put these two values in this, that means I can write this one by putting this value. I can write this one, this v is equal to 6. 6 is equal to, this is k into, in place of t it is 0 plus 6. So if I will put and C, so this will give the C value is equal to 6. Yes. So one value we found out. For the calculating the velocity we found out the C is 6. Yeah. क्योंकि इसको मैं नया कर देता हूँ कोई पुराना वाला काम नहीं कर वो उसमें वो वाला नहीं है
Would you like to try this? Yeah. Sure. I mean, maybe it's the total issue.
Actually, I buy this one new.
I mean, because like, it's like iPad connection is like pushing. Yeah. It's like. 后面有吗 No. Yeah, I mean this switch is switching. It's switching.
You are saying this one has problem?
No, we're just like I ignore it might be one. How about like we shut down this?
Yeah, we can shut down the
Oh, this is much better. 有后面有画面吗？有的话会有，yeah. I mean,
Yeah.
后面有吗？有。
Okay. Thank you again. Okay, so we found the C value is
有吗？有。
So we found the C value is 6. And another thing is that we need to find out this V. We need to find out the V. To find out V when the Y, that is the distance is 3000 and t is equal to 60 seconds. This is what the question is asking. So look, in the beginning, it is saying the run-up is 3 km, and when you take off after 1 minute, what should be the speed of the plane? Right. So let's begin with this v is equal to ktc. So now this particular one we can write v is equal to kt plus 6, because we know the value of c, that is 6. But what is this v now? I can write this v as dy by dt, yes, distance by time, yes, acceleration is velocity by time, then velocity is distance by time, right? By that logic I can write this is kt plus 6, right? That implies I can write this is dy is equal to kt plus 6, I can multiply here dt. Now what I need to do, I will integrate. Now when I integrate, if you carefully read the question, it is saying in the beginning it starts with a particular speed. Initially the plane was in constant mode, then it will start running. That means when the distance was 0, it was there, but it will run for 3000 meters. That means the distance will range from 0 to 3000. So as the time, that is 0 to 60. Yes? So if we go this way, then what is the value? This is 0 to 3000 is equal to kt square by 2 plus 6t, and here we set the limit is, the range is 0 to 60. Now can you solve this one? Simply this one will be 3000 is equal to, because upper bound is 3000, lower bound is 0. So we can simply ignore that one, so this will be 60 square by 2 plus 6 into 60. So if you solve this one, you can get the value, unknown value, that is k. Can you calculate and tell me what is the value of k? Simple mathematics. To calculate, you will get the value of k. Of course, you can use calculator. Engineering mathematics, engineering calculator is you can use. There is no restriction. Yes? Can somebody tell me what is the value? K is how much? Anyone is calculating? Yes? Yes, the last man? Yes, I know you are calculating. Yeah, tell me the answer. Come on. If you have calculated, then tell me the V. KT plus 6. What is the value? V. What is the value of K and what is the value of V? Yeah. Yes.
22/50.
1. 1.6. 46. Okay. And what is the value of V? Something like this. Okay. Some value here. You can calculate 94 point something. Okay. So you have some sense about the application oriented problem. Let's try another one.
Sorry. Can you like scroll down for a bit so I can write the picture of the after calculations? Sorry.
So don't worry, we are recording and we will upload the video. Okay. Okay, so next question, let's say example number 2. Okay, this one I will try to explain you that you can follow how to solve. You need to tell me how to solve, but you guys need to respond to my questions. Okay, so suppose this is a plain area and this is the ground. Okay, so this is the ground. And here is a stone. Okay, here is a stone. And you want to drop this stone to the ground. So here few things is given. The air resistance is 0 and the acceleration constant. So what is that acceleration? When I drop the stone, what is the acceleration?
9.8.
Yeah, gravity. So that is constant, means we can say this is nothing but G. 9.8 meter per second square. Thank you. Okay. So this constant is given. Now the question is, if you drop a stone and we assume that the air resistance is 0 and the acceleration is constant, that is gravity, under what under this assumption, okay, let me frame the question in this way. Since the gravity is this, at what particular, if we drop the stone from a particular height, how much time it takes to hit the ground? That means under this assumption, if we take the height, that means the distance of the height is, let's say, 100 meter or 200 meter something. That means from here, suppose I will drop. So question is, how much time it takes to hit the ground? Okay, that means we are given the distance and we need to find the time. This is the whole scenario. Right. So in this particular scenario, what is given? The acceleration. That means if we take, this is the distance y, so the acceleration is nothing but y double dash, right? If this is the distance, then y double dash is the acceleration. That means this is nothing but the g. That means what is this? Y double dash, this is nothing but dv by dt. What is v? V is nothing but dy dash by dt. So dv by dt, sorry, not y dash, dy by dt. So dv by dt is equal to your z. So I can write your dv is equal to g dt, and if I will integrate both sides, I can get the v is equal to gt plus some constant, let's say c. So this is my velocity. At what velocity the stone will move towards the ground. Now, if I will try to find out the distance, I will start from the v. That means this one is nothing but dy by dt is nothing but zt plus c. And I can rewrite this one, this is nothing but dy is equal to zt plus c dt, and if I integrate both the sides, I can get y is equal to gt square by 2 plus c1 ct plus C1. Right? Now we figure it out, this question. The distance is with the given T and V can be calculated like this. Now here the question is, in this way we can train, the question here, the stone starts at T is equal to 0 from initial position y0 with initial velocity v is equal to v0 right. That implies we can say this y is nothing but okay, let's write like this, so that the solution is y is equal to gp square by 2 plus v0t plus y0 how long does a fall of 100 meter. So it is the same thing we just calculated. So this value we have already calculated. What we need to put, we just need to put these values there. So what is that? Y is equal to gp square by 2 plus v0t plus y0. right? Now here, you just need to put the value. Suppose you are supposed to calculate the distance. If the distance is 100 meter, you just consider y is equal to 100 meter. Because g you know. So here you know what are the, you know y0, you know v0, you know z, and you know y. Because initially you can consider v0 is equal to 0, y0 also is equal to 0, z you know 9.8 meter per second square, y is 100 meter. So only thing you have to calculate is the t, right? Yes, you can easily calculate. If instead of 100 meter, if I'll ask how much time it takes to drop it from 200 meter or 300 meter or 400 meter, just changing the value, you can find out the time. It is that simple. So if you see these problems, these are some physical problems, real life example. In the future classes also you will see some more different types of physical problems. Also I will try to find out some computer science related problems and we will apply engineering mathematics to solve them. Okay. So these are some problems which are given in your book we are referring. So in this way we can solve these problems. Okay. Now the next thing I want to move is something different, that is called Euler method. Yeah, let's take a break, then we will continue after the break. Okay, so let's discuss new, which is called the Euler's method. It's a very interesting concept. I think pretty much most of you are using it in your day-to-day life, specifically related to science studies. So when we try to represent any kind of result, there are basically two ways in mathematics or basically in science. One is computationally we try to represent, or the other way we can represent the graphical. Right. So we mostly represent the solutions. We have the solution. I already told you what type of solution, explicit, implicit, whatever it may be. The solutions we try to represent either graphical or computational. Yes. Now, what is the difference between these two? Suppose I will write sin x. Let's say I write y is equal to sin x. What does it mean? So if I will try to represent using a graph, it will be something like this. So do like this. Yes, this is the sin x, right? But how we get this particular graph? Because if we try to calculate the value of sin x, we can found, like if I just take some value, like if I will take the x value is equal to x and the corresponding sin x. If I take 0, then the sin x will be 0. If I take 30, it is 0.5. If I take 60, it will be 0.87. If I take 90, then it will be 1. So it will be accordingly, if I will put this value, let's say this one is the line for 1, and this one 0, and this one is, let's say, minus 1, negative 1. So I can put this value, let's say 30, 60, 90, and so on. This is 0, 90, then I have 120, 150, then this one will be 180. So all this will give us some value. Sorry, try to compromise with my drawing. So this one is, let's say, for 60, this one is for 50, this one is for 90, which will be 1. And same as this one is 120 for like 87, so 0.87. And here is, you can say, 0.5. And here you have 1. So this one is 0 and 180 is 0. And if we continue like this for the further, like 180, then 210, then 200, further 240, 270, and so on. So accordingly, we can get different values. Now, if we connect these values, we will get this kind of graphs. It is applicable for all kind of functions, right? So this value we are calculating are called the computational values, and the graph we are drawing is the graphical value. So this is how we differentiate computational and graphical. They are interrelated. If they are not exact, they are approximately similar. Okay. So that is what we call the computational and graphical representation. So Euler's method is actually help us to calculate these computational values. Okay, and if you connect these computational values, we will get the graphs. Right. That means if I will put another so suppose I will just draw a simple line, something like this, and I will try to calculate some computational value based on some initial condition. Let's say with the initial condition I get some value like this, and in the next value I get like this, in the next I got like this, and then this, then this, then this. Something like this I get. So then, based on this value, if I will try to connect, then I may get a similar kind of graph. Okay? So based on the initial conditions, I try to calculate the points, computational points. Then when I connect those points, I will get a graph. Okay. Calculating this computational points from that particular method we call the Euler's method. And how exactly we do, so that is we are going to study in this one. Okay. So using, so what exactly we do, if I will specify, using the initial condition, we slowly start generating points after points. Fidelity. So this present a table of points that are all closer to the solution. These solutions may not give the exact point of solution may close to the solution with some error. Okay, so what I explained to you, I just wrote it down. If you have some doubt, you can read it. Okay? So let's understand how exactly this works. Okay? So how does this work? Let's understand. Okay, so let me draw a graph for you. And so this is my x-axis, and this is my y-axis. Okay, and in this axis, what I will draw a graph. Let's say I draw a graph like this. Let's say I will pick a point, this one, which is giving me the y0, and this one is my x0. So this point I choose is x0, y0 point. This point is the x0, y0 point. Okay, this one. So then on this particular point, can I draw a tangent line? If I draw tangent line, it is exactly. So this one is the tangent line I draw on this particular point. I don't think all of you understand what is this tangent line. So if I draw this tangent line, at this particular point x0, y0, so this is x0, y0, and now for any point, x, y, any point x, y, what is the slope? dy by dx. If this one is the initial condition of a particular one, and suppose I want to use another, you can say, what is that? Small distance, let's say h, right? This one is x0. Let's say I will take another one is x1, the next step. So, if I will try to calculate this one, so what is the slope of this tangent line? This is the tangent line. You can see this is the tangent line at this particular point x0, y0, right? Now the slope of this tangent line that is f of x0 y0 is equal to how much? It is nothing but this distance by this distance, right? So let's say this distance is nothing but some value we call h, okay? Because when we put, our input is always x, x0, x1, x2, x3 and so on. So accordingly the y has to be calculated. We don't know what is the y. For x0 we know y0, but for x1 we don't know what is the y, okay? So that y can be calculated, that is particularly depend on this particular value, this one, right? So I can write here, this is nothing but, I will write this one, this question mark I am putting by this h, and I have already told what is this h, x1 minus x0, that is the small value it will take, okay? Although I am putting a long distance here, it is actually a small change, x is changes little bit, okay? So we need to now calculate mathematically. So if I will put it in this way, we start here. Our x is equal to x0 and y is equal to y0, right? Now what is our x1 now? So that is the initial condition, x0, y0. So this one is the initial condition. Right? Now what is x1? What is x1? What is x1? x0 plus h, x0 plus h. Then tell me what is y1? What is y1? It is y0, definitely the y0 plus this one. Yes, that means I can simply write y0 plus h times f of x0 y0. Yes, because this is nothing but, I can write this question mark I am putting here is nothing but h times f of x0 y0, because that is the slope. Yes or no? So then for x2 I can have x0, no, it should be x1 plus h, because I can go for next one, x2, which is another h. I can sequentially go h, x1, x2, x3, x4. Every time I have to increase the h. I have to go for h extension in the x-axis, and I have to find out what is the y. Because every time, first I calculate the slope of x0, y0. Then after I put x1, I will find out y1. Then I have to put the next slope of x1, y1. Then I have to calculate the next x2, y2, and so on. Every time I have to calculate. So then my y2 will be how much? y1 plus h into f of x1, y1, and so on. This process will continue. So this gives us a more generic form for xn is equal to x n minus 1 plus h, and yn is equal to yn minus 1 plus h into f of xn minus 1 into yn minus 1. Any problem? Anybody confused? I feel some faces are quite confused. Yes? If you are confused, don't worry. We can still solve it with one example so that it will give more clarity. Right? So this is how the Euler's method is derived. So this h we call its step size. Okay. So in general, how we write the Euler's method? dy by dx is equal to f of xy, y x0 is equal to y0, and step size is equal to h. And then we can say xn is equal to xn minus 1 plus h, and yn is equal to yn minus 1 plus h, the Euler's method for calculation of okay. So let's take one example. So what is given here, y is equal to x plus y dash is equal to x plus 2y, y0 is equal to 0, and h is equal to 0.1. Question is approximate y 0.4 using Euler's method. Okay. So what is given? dy by dx dy by dx is equal to x plus 2y and h is equal to 0.1. So this is our fx. Fxy, right? This is the y dash dy by dx, and this is our h, the step. So we can start. Your x0 and the y0. X0 is 0, y0 is equal to 0. Right? Which is initial condition given. This is the initial condition. Next, x1. What should be x1? It should be x0 plus h. That is 0 plus how much? What is h? 0.1. That is x1 is 0.1. Our x1 is 0.1. And what is y1? X plus 2y. X plus 2y. Y0 plus h into f of x0 y0. What is fx0? So what is y0? You can put y0 is 0 plus h is 0.1. Then fx0 y0, what is that? 0 plus 2 0. Great. So how much are you getting? Y1 is still? Oh. Zero. Then we can calculate for x2. x1 plus h, that is 0.1 plus 0.1, that is 0.2. And same is we can also calculate y2 is equal to y1 plus h into f of x1 y1. What is y1? y1 is 0 plus h is 0.1 into x1 y1, f of x1 y1. You know what is x1? x1 is 0.1 plus term is 0. How much? With 0.01. Right. Then x3 h2 plus h, that is 0.2 plus 0.1, that is 0.3. Y3 is y2 plus h into f of x2 y2. So you can easily calculate what is y2, 0.01 plus h, 0.1 into f of x2 y2. That is x2 is 0.2 plus 2 times 0.01. Right. So in this way, if you calculate how much, it will be 0.03. Same we can also apply for x4. It will be 0.3 plus 0.1, that is 0.4. So this is what we are looking for. My tablet is dying. Okay, so you can apply this one. So how could I recharge this one? If I will recharge, I cannot display. Okay. Can I recharge? Yeah. Anybody have charger here?
You can swap to your dongle if your dongle is supported.
Yeah, but I didn't bring my charger.
I mean-
I was quite confident with my tablet. You have charger?
I think the dongle has
Yeah.
the one I gave you.
The adapter.
Okay, you have.
You have? Finally, get oxygen. Okay, so this is what we got here. Is the x4 is this one. Then what is my y4? Is y3 plus h into f of x3 and y3. That is 0.032 plus 0.1 into how much? 0.x3, right? 0.3 and yeah, how much? 0.364. Yeah, you calculated, okay? So 0.0364. Okay, I'm using this one.
No, I mean fx.
Yeah, if you will calculate, it will be something like this. Okay, so this is when, so my question was, what was the question? Approximate. What is y04? That means when x4 is equal to 0.4, y4, I mean x, when x is equal to 0.4, what is the y? So this is my y4, that is the y.
No, I mean 0.1 times 0.0364. It's in the parameters.
Yeah.
So final answer would be 0.0684.
Yeah, that's right.
Final right?
Okay. Yeah. So this one supposed to be 0.0684, right?
Yes.
Yeah, so this one is the final answer y. So now if you put these values in a graph, like suppose I will draw a graph like this with, let's say, 0.1, 0.2, 0.3, 0.4, and what is the value for 0.0? y1 is 0. 0. Then y2 is 0.01. So y1 is 0. This one is 0. Then maybe 0.01 is this one. Then it can go to 0. Let's say something like here, and then it will go something somewhere like this. I'm randomly putting some values. So this is, let's say, 0.1, 0.2. I put maybe a little larger. So let's say this is 0.1, maybe 0.2, and this one is okay. In a better way. Let's say this is 4, and somehow the line will go up 0.5 and something 0.6, something here. So then the line should be it will be 0, then somewhere here, then here, then it will go to here. So the line could be something like this, you can draw. So this is overall idea about how the Euler's method help you to calculate. And this is when we write the code in our program to draw a graph of sin x or sin x. Actually, the computer calculate these things and then it draws for you. So something happened behind the computer for you. So this is overall idea about how the Euler's method works. I believe all of you have some idea, and please go through if you are not following this one here, please go through the video again so that you can have some idea. And possibly in the next class we will start a different chapter, that is separable coding. We can discuss it more in the next class. Thank you very much. You saved us.